All right, we're going to do the 2.8 notes now, which are product rule. So the product rule is written right here, and that's when you're multiplying two different functions together, f of x being the first function, g of x the second. So when you do the derivative of these products with respect to x, there are two ways to do it. The first one is you take the derivative of the first times the second plus the first function times the derivative of the second. I always do this one, so I'm always going to say first derivative of the second plus the second times derivative of the first. So first derivative of the second plus second derivative of the first. Either one's fine. A lot of people use the other one. It is all equal because of commutative property of multiplication. So when I do this first problem here, my first function is this 3x minus x squared. This is my first. And the product, the second thing, is this function over here, 5 plus 4x. That's the second part right there. So I'm going to make this thing skinnier so it's not so huge. So when I do the derivative of h, you take the first function, which means leave it the same, times the derivative of the second function. Well, the derivative of 5 is 0, and the derivative of 4x is 4. And then it's plus the second function, so I write it exactly like it is, times the derivative of the first function, which the derivative of 3x is 3, and the derivative of negative 2x squared, you take 2 times 2 is negative 4, and lower that power by 1. So there's your derivative. You're done right there. I would like you to practice your algebra skills. So we're going to distribute that 4 in there and get 12x minus 8x squared. And then over here, we're going to FOIL this part over here on the right. So we're going to take 5 times 3 is 15. 5 times negative 4x is negative 20x. 4x times 3 is 12x. And 4x times negative 4 is negative 16x squared. And then we would combine the like terms. Now, since my x squareds are negative, I'm going to write it in ascending order of powers. 15 is my only constant. I got 12x plus 12x is 24x minus 20x, so that would be plus 4x. Now I have a negative 8x squared and a negative 16x squared, which is going to end up being negative 24x squared. And again, this top thing's the answer. One thing you're going to find out about when we do derivative rules is it makes the problem more advanced, more longer. So when I do the product rule, it makes this thing really long, but you can always reduce it. Now this said, do we have to use the product rule for example 1? And the answer would be no. We could have FOILed this together and got a x to the third power, a cubic problem, and then done the derivative of that cubic problem and got this same answer. But we want to practice product rule today. So we're going to do the derivative of this. So my first term is x, my second term is sine x. So when I do the derivative of a product rule, I always take the first term, derivative of the second term, plus the second term, times derivative of the first term. Now, I would not normally write the 1 because 1 times anything is itself. So that thing right there is my derivative, first derivative. Over here, I got e to the x as my first term and x is my second term. So I get g prime of x is going to be the first term times derivative of the second term plus the second term times derivative of the first term. So this is going to be e to the x plus x e to the x. Now, some ways they might write this is they might factor a common factor of e to the x out here. So they might write it e to the x times the quantity 1 plus x as well. So any one of these three answers could be an answer that they could write on the AP test. So we're going to do, this is kind of a combination of several rules. So the first one is going to be a product rule because 2x is my first term and cosine x is my second. So I'm going to take the first term times the derivative of the second term. The derivative of cosine is negative sine x plus the second term times the derivative of the first term. And then this is just one term in itself because negative 2 is a coefficient. So I'm going to leave the coefficient there and the derivative of sine is cosine x. I would want to straighten all this stuff out. So this is going to be negative 2x sine x. And this becomes the coefficient of the cosine. So this is plus 2 cosine x and minus 2 cosine x. And I hope you see these two are like terms and they're going to cancel each other out. So this whole thing just becomes -2 sine x. Okay, over here we're going to use some other rules. And this is product x squared. I hope that's x squared. That's what it looks like to me. And natural log of x. So this is going to be k prime of x is going to equal the first term x squared times the derivative of the second term, which is 1 over x, plus the second term natural log of x times the derivative of the first term, which is 2x. So this x squared, one of these will reduce with this. So I'm going to be left with x plus, and we usually want to put the 2x in front of natural log of x. So that right there is good enough for now for the derivative. The last page on here is an actual problem, which almost looks like it's from an old AP test. So it says the differentiable functions f and g are defined for all real numbers x. Find values of f prime, g, and g prime are in this table. So we want to find all this stuff. So this one, we're going to do product rule for this. So we're looking for h prime of 3, but first we want to do the derivative of this. So I hope we can see that f of x is my first term, g of x is my second term. So again, first term times derivative of the second term plus the second term times derivative of the first, oops, I said second derivative. Second term times derivative of the first term. Now there's my derivative and I'm trying to find h prime of 3, which means I'm going to come over here and plug 3 in for all my x's. And once I get these plugged in, I'm then going to go up to my table and find their values. So I need f of 3. So here's f. When x is 3, that's 1. So I'm going to stick a 1 in for that f of 3. G prime is here, and I want g prime of 3. There's 3, so g prime of 3 is -4. And then I got g of 3, which g is here, 3 is there. This is also -4. And f prime of 3, there's f prime, and 3 is there, so this is 8. And then I'm going to simplify all this. So this is -4 minus 32. So this whole value would be -36. Now again, once you plug these numbers in right here, I could have stopped right there and been fine. That way I wouldn't have to worry about making a mistake down here. Product rule again here. So we're doing the derivative of this first term and this second term with respect to x. So when I do this thing right here is going to equal the first term. I'm going to write it as x to the half right now because I should be thinking of this as x to the half when I do a derivative. So x to the half times the derivative of the second term is f prime of x plus the second term is f of x. And then the derivative of x to the half is a power rule. So we bring the half to the front. We subtract 1 from a half. That makes -1/2. And then I'm going to simplify all this. So this is square root of x, f prime of x plus f of x. And then we would want to move this x down to the bottom with the 2. And I'm going to put it back in a radical because it'll be x to the half down here like this. And now I'm supposed to find this when x is 4. So what I'm going to do is I'm going to have the square root of 4 times f prime of 4 plus f of 4 times 1 over 2 times the square root of 4. So I hope we all know the square root of 4 is 2. I hope we know the square root of this 4 is 2. So this out here is end up being 1/4. And now I got to go up to my table. So f prime of 4 is -1. So this is going to be -1. And f of 4 is going to be 10. So this is going to be -2 plus 10 over 4. Or I could reduce that to 5 over 2. So that'd be plus 2.5. And when I combine those, I get a half. So that would be the answer to that. And that is the end of the 2-8 notes. So I will talk to you guys later.